Imagine our planet's entire long history squeezed into a single day. Earth is very old, about 4.5 billion years old. That number is so big it's hard to picture. So, let's use a cosmic calendar, a 24-hour clock, to make sense of it all. On this clock, every second represents more than 50,000 years of real time. Every minute is almost 3 million years. Every hour is a staggering 187.5 million years. This special clock will be our guide on an incredible journey through deep time, from the very birth of our world to this exact moment. Our story begins at midnight, 00 hours on the clock. At this moment, there is no Earth. There is no sun. There is only a vast, swirling cloud of gas and dust left over from older, long-dead stars. This cosmic nursery holds all the ingredients needed to build our solar system. Gravity, the great cosmic sculptor, begins to pull this material together. It gathers more and more matter, spinning faster and faster until the center of the cloud ignites. A new star is born, our sun. This grand event marks the true beginning of our cosmic day. As we watch this 24-hour story unfold, we will see our planet take shape from rocky debris. We will witness the violent creation of our moon and the formation of the first oceans. For most of this day, life will be simple, microscopic, and hidden from view. The world we know, with its forests, animals, and cities, only appears in the final moments of this cosmic day. The grand saga of dinosaurs, a story that feels ancient to us, plays out late in the evening. And humanity? We are a mere blip, arriving in the last seconds before midnight. This journey through Earth's 24-hour day is more than just a history lesson. It is a story of change, of destruction, and of incredible creation. It shows us how connected everything is, from the stars above to the ground beneath our feet. We will encounter great mysteries that scientists are still trying to solve, like giant missing pieces of our planet's rock layers. We will see how life persisted through planet-freezing ice ages and devastating asteroid impacts. So, let's step into our cosmic time machine and begin our adventure at the very first second of Earth's day. The clock starts ticking at midnight. At 00 hours, our Earth is born. It is not the blue and green world we know today. Instead, it is a hot, molten ball of rock, a fiery inferno constantly bombarded by asteroids and comets left over from the solar system's creation. A day on this early Earth is incredibly short, lasting only about 6 hours. The planet spins wildly, a chaotic and hostile place. There are no oceans, no continents, and certainly no life. This is the very beginning of our world's story, a period of intense and violent construction. Just 40 minutes into our cosmic day, at 0:40, a truly cataclysmic event occurs. A young planet, about the size of Mars, which scientists have named Theia, is on a collision course with our own. It slams into Earth with unimaginable force. The impact is so powerful that it melts both worlds and throws a massive cloud of vaporized rock into orbit. This glowing ring of debris, held by Earth's gravity, slowly begins to clump together. Over time, these pieces merge to form a single large body, our moon. This violent birth shaped both our world and its constant companion. Following this colossal impact, Earth begins a long, slow process of cooling down. By 0113 on our clock, something amazing starts to happen. As the planet's surface cools, water vapor that was trapped in the atmosphere begins to condense and fall as rain. This isn't just a shower. It is a relentless downpour that lasts for millions upon millions of years. This water, along with more delivered by icy comets and asteroids, fills the vast, low-lying basins on Earth's surface. The first oceans are born. These were not the cool blue oceans of today, but hot, acidic seas under a thick, hazy sky. Even with oceans, the young Earth remains a strange and alien world. The moon is much closer than it is today, appearing huge in the sky and creating enormous tides that sweep across the globe. This gravitational tug-of-war between Earth and the moon gradually slows our planet's rotation, making the days longer and longer. Meanwhile, deep beneath the hot oceans, near fiery volcanic vents, a different kind of chemistry is taking place. In these natural underwater laboratories, simple molecules are beginning to combine, forming the first complex building blocks of life. The stage is being set for the next great act. For hours on our cosmic clock, the planet simmers. The oceans are a chemical soup, full of organic molecules created near hydrothermal vents and delivered by space rocks. Then, at around 4:30 in the morning, the greatest miracle of all occurs. Somewhere in that primordial sea, a collection of these molecules crosses a threshold. They organize themselves inside a protective membrane, creating the first fully formed cell. This is it, the official beginning of life on Earth. It is just a single, simple microbe, a bacterium, but it holds the potential for every living thing that will ever exist. This first life is incredibly basic. It is a prokaryote, a cell without a complex inner structure like a nucleus. For more than 1 billion years, these tiny organisms will be the only form of life on our planet. They float in the oceans, consuming the chemical nutrients around them. From the outside, Earth would still look like a barren water world. But beneath the surface, a quiet revolution is underway. Life is learning, adapting, and slowly changing the very nature of its home. It is a hidden microscopic dynasty that reigns supreme for an immense stretch of time. As morning turns to midday on our cosmic clock, life makes another crucial leap. Around 11:13 a.m., a new type of bacteria evolves: cyanobacteria. These tiny organisms develop a revolutionary new skill called photosynthesis. They learn how to use the energy from our faint young sun to create their own food. This process is a game changer, but it also produces a waste product. That waste is a gas that will one day become essential for us, but at the time, it is a deadly poison to most other forms of life. That gas is oxygen. This new kind of life flourishes in the sunlit upper layers of the ocean. These cyanobacteria form vast colonies, creating structures called stromatolites, which can still be found as fossils today. They are Earth's first great engineers, tirelessly pumping a toxic gas into the water and the atmosphere. For hundreds of millions of years, this oxygen reacts with iron in the oceans, causing it to rust and settle on the seafloor in huge layers. But eventually, the iron runs out. The stage is set for a planetary crisis that will change the world forever. Just after 11:30 in the morning on our 24-hour clock, the crisis begins. The cyanobacteria have been so successful that free oxygen finally starts to build up in the atmosphere. This is called the Great Oxygenation Event. For the anaerobic life that dominated the planet until now, life that cannot tolerate oxygen, this is an apocalypse. The very air becomes toxic, triggering the planet's first and perhaps greatest mass extinction. The world that had existed for billions of years is wiped away, replaced by one that can support a new kind of biology based on oxygen. The consequences of this atmospheric change are enormous and far-reaching. As oxygen fills the air, some of it, high up in the atmosphere, is transformed by the sun's radiation into ozone. An ozone layer begins to form for the first time. This layer acts as a planetary shield, blocking much of the deadly ultraviolet radiation from the sun. Before this shield existed, life was confined to the safety of the oceans. Now, with the ozone layer in place, the land surfaces of Earth would one day become safe for life to colonize. This new, oxygen-rich world paves the way for another monumental step in evolution. At around 1:39 p.m., a new type of cell appears, the eukaryotic cell. This happens through a process called endosymbiosis, where one simple cell engulfs another, and instead of digesting it, they form a partnership. A small bacterium that could use oxygen to produce energy becomes the mitochondria, the powerhouses of our own cells. This new complex cell, with its protected nucleus and internal machinery, is far more efficient and powerful. It is the ancestor of all plants, fungi, and animals, including us. For hundreds of millions of years, these new eukaryotic cells continue to evolve in the oceans. Then, around 5:47 p.m., in the late afternoon of our cosmic day, another incredible milestone is reached. Some of these cells begin to cooperate, sticking together to form the first multicellular life. We see the first algae and the first fungi. This is a huge leap from single-celled existence. These organisms are the pioneers of complexity, developing specialized cells that perform different jobs. The world is on the cusp of another biological explosion, but first, it must survive a deep freeze. As we explore Earth's story, we find that it is written in layers of rock, Like pages in a book, these layers tell us about the oceans, mountains, and living things of the past. But in many places around the world, from the Grand Canyon to the mountains of Scotland, geologists have found that a huge number of pages are missing. This mystery is called the Great Unconformity. It is a massive gap in the geological record, where ancient rocks that are billions of years old lie directly beneath much younger rocks, only about 500 million years old. What could have happened to erase over 1 billion years of Earth's history? Imagine a book where you have page 50, and the very next page is 500. All the chapters in between have been torn out. The missing rock layers represent a time period up to 1.4 billion years long. That's more than a quarter of our planet's entire existence, just gone. Scientists are still debating what could have caused such a colossal loss of rock from all over the planet. It is one of the most profound puzzles in geology, a planetary amnesia that hides a key part of our world's youth. One leading theory points to a period of extreme cold, known as Snowball Earth. This idea suggests that our entire planet was covered in thick sheets of ice, miles deep, around 650 million years ago. As these colossal glaciers moved across the continents, they would have acted like giant bulldozers. They could have scraped away trillions of tons of rock and sediment from the land masses, grinding them down and dumping the debris into the oceans. This global-scale erosion could explain how so much rock history was scoured away from the continents. Another powerful idea is linked to the breakup of an ancient supercontinent called Rodinia. Before the continents we know today, all of Earth's land was gathered into one giant mass. When Rodinia began to rip apart, the process would have caused immense geological upheaval. The land would have been pushed upwards, creating vast mountain ranges. This uplift would have exposed enormous amounts of rock to erosion by wind and rain for hundreds of millions of years. This epic erosion event, possibly combined with the Snowball Earth glaciers, could be the culprit behind the missing time. Our cosmic clock now reads 8:38 p.m. Earth has just thawed from a deep global freeze, the Snowball Earth event. This extreme ice age was a powerful filter for life, but its end brought new opportunities. As the glaciers melted, they dumped huge amounts of nutrient-rich minerals into the oceans. The world that emerged was a blank slate, a transformed planet ready for life to take over in new and spectacular ways. The survivors of the Great Freeze found themselves in a world ripe with potential, setting the stage for an unprecedented evolutionary boom. Immediately following the thaw, the first large, complex, and strange life forms appear. This is known as the Avalon explosion. These creatures, called the Ediacaran biota, are unlike anything alive today. They were soft-bodied, quilt-like organisms that lay on the seafloor. Some looked like fronds, others like segmented ribbons or flattened discs. For millions of years, they were the dominant form of complex life in the quiet, murky depths. They represent the first grand experiment in building large, multicellular bodies, a strange and mysterious chapter just before life truly exploded. Then, at 9:12 p.m., the fuse that was lit after the Snowball Earth finally ignites the Cambrian explosion. In a relatively short burst of geological time, life becomes dramatically more diverse and complex. The oceans, once home to simple, soft creatures, are suddenly filled with animals that have hard parts, shells, skeletons, and teeth. We see the appearance of trilobites, armored arthropods that scuttled along the seafloor, and among the strange new creatures is a small, worm-like animal called Pikaia, which has a primitive backbone. It is one of the first chordates, a distant ancestor of all vertebrates, including us. The Cambrian explosion forever changed the nature of life on Earth. With the evolution of hard parts, a new dynamic emerged, the arms race between predators and prey. Animals developed armor for protection and sharp claws and teeth for hunting. Life was no longer passive. It was active, competitive, and fierce. This burst of innovation established the basic body plans for almost all animal groups that exist today. It was a biological Big Bang that happened in the dark depths of the ocean, forever shaping the tree of life. As the evening progresses on our cosmic day, life begins its conquest of the land. Around 9:34 p.m., simple moss-like plants start to colonize the damp edges of the continents. They are soon followed by the first land animals, brave arthropods, like ancient insects and millipedes, venturing out of the water. By 10:05 p.m., vertebrates join the invasion. Amphibians, descended from lobe-finned fish like Tiktaalik, use their sturdy fins as primitive legs to haul themselves onto the shore. Life is adapting to a whole new world of air and gravity, a major step in its expansion across the globe. Meanwhile, the continents themselves are on the move. Driven by the slow, powerful motion of plate tectonics, Earth's landmasses drift together once again. By about 10:16 p.m. they collide to form the last great supercontinent, Pangaea. All the world's land is joined into a single, immense continent surrounded by a global ocean. This new geography dramatically changes climates around the world. Vast deserts form in the interior of Pangaea, creating harsh new environments that drive the evolution of reptiles, the first vertebrates, to be completely free from the water for reproduction. This new world belongs to the reptiles, and from them, a spectacular new group of animals evolves. At 10:48 p.m., the first dinosaurs appear. They are different from other reptiles because of their upright stance, with legs positioned directly beneath their bodies. This innovation allows them to move more efficiently and grow to enormous sizes. For the next 160 million years, a huge stretch of time, dinosaurs will dominate the planet. They diversify into an incredible array of forms, from the giant, long-necked sauropods to the fearsome tyrannosaurs and the armored stegosaurs. This is truly the age of dinosaurs. During their long reign, the world changes again. The supercontinent of Pangaea begins to break apart, slowly forming the familiar continents we know today. The first birds, like Archaeopteryx, evolved from small, feathered dinosaurs taking to the skies. The first flowering plants appear, adding color to the landscape and forming new partnerships with insects. The world is vibrant and full of life, ruled by magnificent giants. But their time is running out as our cosmic clock approaches 11:39 p.m. A visitor from deep space is on a collision course with Earth. At exactly 11:39 p.m., with just 21 minutes left in our planet's day, disaster strikes. A massive asteroid, 6 miles wide, slams into the ocean near what is now Mexico's Yucatan Peninsula. The impact releases more energy than 1 billion atomic bombs. It triggers earthquakes, tsunamis, and volcanic eruptions around the globe, and sends a cloud of superheated dust and debris into the atmosphere, blocking out the sun. The world is plunged into a long, dark winter. This event, known as the Chicxulub impact, causes a mass extinction that wipes out 75% of all species, including all the dinosaurs, except for their bird descendants. The end of the dinosaurs is a tragedy, but it is also an opportunity. For millions of years, mammals had been living in the shadows of the giant reptiles. They were mostly small, nocturnal creatures, scurrying to survive. With the dinosaurs gone, the world is suddenly open for them. In the minutes following the impact, mammals begin to diversify rapidly, filling the empty ecological niches. Just 1 minute after the impact, at 11:40 p.m., the first primates appear. These small, tree-dwelling ancestors of monkeys, apes, and humans have grasping hands and forward-facing eyes, adaptations perfect for a life in the trees. The clock ticks closer and closer to midnight. The world begins to look more like the one we know. Then, in the final 2 minutes, a new lineage of apes in Africa begins a remarkable journey. At 11:58 p.m., driven by a changing climate that turns forests into savannas, hominids like Sahelanthropus begin to walk on 2 legs. This frees up their hands to carry food and eventually, to make tools. This is the dawn of the human family. At 11:59 and 13 seconds, Homo habilis, the handyman, appears, the first of our genus to craft stone tools. The final seconds before midnight are a whirlwind of human evolution. Homo erectus emerges, masters fire, and migrates out of Africa. Neanderthals evolve in Europe, developing complex social behaviors, like burying their dead. Finally, at just 6 seconds to midnight, 23:59:54, our own species, Homo sapiens, appears in Africa. For a brief time, we share the planet with other human species. We migrate across the globe, and in the very last second, we invent agriculture, build pyramids, start an industrial revolution, and connect the world with the internet. All of human history flashes by in the blink of a cosmic eye. Our 24-hour journey through deep time has come to an end. We have traveled from a ball of fire and rock to the complex living world we inhabit today. We saw how a violent collision gave us our moon, how tiny microbes poisoned and then saved the world with oxygen, and how life exploded into a dazzling array of forms after a global ice age. We witnessed the rise and fall of supercontinents and the long dramatic reign of the dinosaurs, and in the very last seconds, we saw ourselves arrive on the scene. Understanding this immense history is important for everyone. It gives us a profound sense of perspective. It shows us that our planet has gone through radical changes, far greater than anything humans have yet experienced. Ice ages, asteroid impacts, and mass extinctions are all part of Earth's story. Our world is not static. It is a dynamic, ever-changing system. Knowing this helps us appreciate the delicate balance of the environment we live in today, and the powerful forces that can disrupt it, both natural and of our own making. This story also teaches us about our own origins. We are not separate from the history of our planet. We are a product of it. The oxygen we breathe was created by ancient bacteria. The carbon in our bodies was forged in the hearts of long-dead stars. Our family tree connects us not just to our primate ancestors, but to the first fish that crawled onto land, the first complex cells, and the very first spark of life in the primordial ocean. We are a continuation of an unbroken chain of life that has survived on this planet for nearly 4 billion years. Ultimately, the story of Earth is our story. It is a tale of resilience, adaptation, and the interconnectedness of all things. By looking back into the deep past, we can better understand the present and make wiser choices for the future. We are the first species on this planet capable of understanding this grand narrative. We have the privilege and the responsibility to learn from it. As we stand here, at the stroke of a new cosmic midnight, the future of our planet's next day is, for the first time, in our hands.